So far we've worked with rational expressions in terms of multiplication, addition, and subtraction, whether it's like denominators or unlike denominators. And then the last type of operation we need to work on is dividing. These are technically polynomials. We're going to start off pretty easy right now in the fact that we're going to be working with dividing by a constant number, and then we'll work into an actual polynomial. So for instance, let's say that I had 8x squared plus 4x plus 1, and that was all over 4. Okay, so with this, that 4 goes into everything in the numerator. So it goes to the 8x squared, it goes to the 4x, and it goes to the 1. So as you can see, I've just broken this up into each individual term. With that, I can now go ahead and simplify each specific term. So if I look at the first term here, I've got 8 divided by 4, which gives me 2x squared. With this, I'm getting rid of that fraction when I do this. Plus, then I've got 4x over 4, which reduces down to just a 1x. And the 1/4 doesn't actually reduce, so that's my only fraction term within my answer. So now I've divided each term. Let's do another one of these. So for this one, let's say that I have 6x squared minus 18x. Yeah, we'll go cubed on that one. Plus 12x. And that's all over 3x. So I'm going to break each one of these down. I'm going to go ahead and rearrange this to the 18s first since it's cubed. Sorry, I started it and then I thought I wanted to do something different. So I've got negative 18x cubed divided by 3x plus 6x squared over 3x plus 12x over 3x. So now I have that 3x into each term, and I'm going to go ahead and reduce. So negative 18 over 3 gives me a negative 6, but now I got to look at the x's, and that drops down to an x squared. The next term, 6 divided by 3, gives me 2, and the x's just drop down to 1x. And the last term, I get a plus 4. And technically with this one, the x's cancel. Now, yes, this is my answer, but sometimes if you're still left with a fraction, you may want to keep going. So if you notice here, I can factor out a 2. Now I'm left with negative 3x squared plus 1x plus 2. And then you might need to factor depending on what you're doing. All right, so that's when you have a single term. When you have a binomial with your division. So for instance, if I want x squared plus 3x plus 2 divided by x plus 1. Okay, now this gets a little bit different. We're going to set this up as a long division so that x plus 1 goes on the outside. So here is my goal. My goal in terms of long division is to have a number here that's going to be distributed to both of those, and that's going to give me this spot right here. Okay, now I know that if I'm working with this spot here and it's being multiplied by the x, my goal is to get an x squared. I know that that's what I'm trying to get. So I need to figure out what times this x over here gives me x squared. Which is just a regular x. So then I have to, that's the distribution here, then I have to distribute it to the 1, and that's a plus 1x. So with any long division, I know that I have to subtract. So I've got x squared minus x squared, which gives me 0. That was my goal. Then I have 3x minus 1x, which gives me 2x. And then I'm going to drop down that plus 2. So now I know that I have to get 2x somehow. And it's going to be with this next term being distributed to the x plus 1. So if I'm looking at that, I already have an x on the left, but I need a 2. So I'm going to put a plus 2. I'm going to go ahead and distribute, and that gives me that 2x, and then 2 times 1 gives me plus 2. I go ahead and subtract, and I have a remainder of 0. So what this means for me is that x plus 2 is my final answer. We're going to do another one of these. Let's say that this time I have 2x plus 5, 6x cubed plus 11x squared plus 4x plus 35. Now this one's a little bit longer, but it's good practice. So I already know that I'm going to get a 6x cubed because that's what I'm looking for. So this number here is being distributed to the 2x and the 5. So with that being said, what times 2 gives you 6? That would be a 3. And then from there, I need an x cubed. I have an x on the left, so I know that this has to be x squared then. So if I distribute that to the 2x, so I already know I'm getting that 6x cubed. Now I distribute the 3x squared to the 5, and I get a plus 15x squared. Now I'm going to go ahead and subtract these. I know that x cubed is going to eliminate. Now I've got 11x squared minus 15x squared, which is a negative 4x squared. And then I drop that 4x. I'm moving on now to the next term, and I know that it has to be a negative 4x squared. So I have that 2x on the left, so it's going to be a negative 2 in order to get that negative 4. I have an x over here on the left, but I need another x to get that x squared. So now I distribute that negative 2x to the 5, and I get plus 10x. I'm going to go ahead and subtract. The negative 4x squareds we know cancel. Now I've got 4x minus 10x. Except I did one minor mistake here, and I just noticed it. If you notice here, it shouldn't be a plus 10x. It should be a minus, because I've taken that negative 2x times a 5. Sorry about that. But continuing on here, I've got 4 minus negative 10, so that'd be a positive 14x, and then I'm dropping down that 35. So now my goal is to get that 14x again. So I've got 2x on the far left. In order to get 14x, it's going to be a plus 7. And then I need to distribute that 7 to the 5. Double checking here, positive times positive gives me a positive 35. I'm going to go ahead and subtract, and I get a remainder of 0. So my final answer is then 3x squared minus 2x plus 7. Now, you might be wondering what happens when you have a remainder. If you have a remainder, you take that remainder over what you divided by. But for us, our remainder was 0. So 0 over anything is 0, so that's why it doesn't show up there. So if you have a remainder, you put that number on the top and then do 2x plus 5 or whatever you're dividing by in the denominator, and that's how you take care of that remainder.